Hi, everyone. We are the IrriGator team, an adaptive irrigation system. My name is Reed Russell. I'm a computer science major and math minor.
My name is Jack Story. I'm a computer science major.
And my name is Max Dennis, and I'm an electrical engineering major.
So the purpose of our project was to develop a home irrigation system that adapts to environmental conditions and provides efficient water usage for homes. We worked really close with Texas Instruments, specifically Michael's Word was our sponsor, not to develop it as a product for Texas Instruments, but rather just with their support. They provided us with several key hardware components that allowed our system to work. So our technical solution, we came up with what consisted of two main components, the actual hardware and the software. The software was responsible for collecting and formatting the data that we would use to inform our scheduler. This includes moisture data and water flow data, and then also weather data that's pulled down from the internet. The hardware controlled the flow of water through the system and provided the actual data components that inform the software. So these are our hardware components on the left, and Max will talk about that in the next slide when we see our actual system. But in terms of our software, our front end is running a bootstrapped JavaScript framework with a MongoDB database and a Node.js backend. And we're also running several Python scripts that collect and format the data from the sensors and sends that up to the database. Now, this is all hosted on a Raspberry Pi, which is the brains of our system. And this is what controls all of the components.
So in the top left image, you can see that our system was connected just to a regular hose. And then in the top right, we have the moisture sensor module, which consists of a solar-powered moisture sensor to get data from the soil, which was transmitted wirelessly via sub-1 gigahertz MCU. In the bottom right, you can see our main hardware components connected to the Raspberry Pi. This consists of the solenoid and a relay, which was controlled by the Raspberry Pi, as well as the ultrasonic flow sensor, which transmitted water usage data to the Raspberry Pi. And then in the bottom left, you can see our drip irrigation piping.
So Jack is now going to run us through the demo of the front end.
Yeah, so this landing page here is what we like to call the irrigated dashboard. This displays chance of rain, water used this year in gallons, your current location, the last time your database was updated. And then these charts are nice because they help you kind of visualize what your water use looks like. So this chance of rain chart helps with forecasting. This water use chart, you can see how much water has been pumped where. This current moisture level by zone chart is informed by our moisture sensors. So if we have 3 sensors in the yard and we know that this zone is pretty wet, this zone is not very wet, and this zone is really dry, we know where in the yard we need to send the water. This view this also displays the 3-hour forecast as well as an hourly forecast for wherever you are. And the water use history table collects all the data from the water pumping system and displays it as like runtime, minutes, gallons used, and then. So thank you for reviewing our demo.